Well, hello everyone. Thank you for joining me today. My name is Yeva. I am web scraping engineer at Oxylabs, a market-leading web intelligence collection platform. And web scraping is our core expertise. My daily work involves developing and maintaining tools, helping our clients easily gather the data they need. Today, I'm going to talk about something that often gets overlooked in discussions around AI. Data collection, and more specifically, web scraping, plays a big role in both powering AI and benefiting from it. Ultimately, web scraping and AI forms a powerful partnership, and in this session, we'll take a deeper look at why. So the web is a great source of up-to-date information on anything you can think of. And when we need large volumes of this information, what do? We scrape it. So simply put, web scraping is automated collection of data from websites. By extracting this data at scale, companies can analyze and leverage this information in countless creative ways. So under the hood, a scraper, usually a script or a specialized tool, sends an HTTP request much like a browser does. This request goes through a proxy and then reaches a target site, which then generates a response, typically an HTML document, which travels back the same route. This request-response cycle is the foundation of web scraping. Scrape data powers many applications, but most of them can fit into three major buckets, which are analyzing the past, predicting the future, or powering AI models. For example, you can scrape the same web page in regular time intervals and compare how that information changes over time. A popular use case is scraping Google search results, checking how well your company ranks amongst those results and comparing that to the rank a week ago. Or scraping historical data can help businesses spot important trends too. For instance, companies can scrape competitors' prices and sales information, and after analyzing this information, they can see how customer behaviors and pricing strategies change over time. And that can help them make smarter decisions. Or using historical scrape data combined with predictive analytics, businesses can predict future market demands. For example, if you continuously scrape travel websites, you could forecast how busy a location will be a month or a year later. This can help hotels or airlines adjust their prices dynamically. Or you scrape tweets mentioning your company name, you spot a few negative mentions early, and now you can predict if a PR storm is coming your way or is it just a minor drizzle. Now let's talk about how scrape data powers AI in two different phases. Let's start with the training phase. So you might have already heard of Common Crawl. It's a nonprofit organization archiving public web content since 2007. Many popular LLMs have been trained on their corpus, but it comes with the limitations. Firstly, it's not that huge. Common Crawl's archive is massive, but it's far from being a copy of the internet. They only add around 3 to 5 billion web pages a month, and that's not that much data considering there's over a billion websites with thousands of web pages with content that may change daily or even hourly. Also, it gets blocked a lot, meaning it misses on a lot of protected content. Anyone can use the same data set too. That means there's no competitive edge. And all the data there requires significant cleaning efforts too. And it's also outdated. They only update it only once a month. And you normally only get text HTML, so there's a modality problem as well. Now, freshly scraped data, however, fixes all these issues. It solves the limitations of public datasets like Common Crawl by providing the data exactly when you need it without unwanted gaps or unacceptable content. It can be tailored to your specific needs as well, meaning that you can scrape precise websites and topics that are relevant for your business. It's fully up-to-date and accurate, reflective of current moment and trends, and it can be multimodal as well. So scraping can provide you audio, video, images, and other valuable data types too. Okay, and now for the generation phase, this can be split into two different ways where that scraped data can be used here. So in cache augmented generation, AI pulls from cached previously scraped stored data. It's fast, but it can be outdated. And this approach doesn't really reflect real-time changes. While in retrieval augmented generation, data is scraped in real time as the model needs it. RAG applications generate content and serve the results to their users on the fly. And to power RAG applications, scrapers need to be accurate and fast, as ultimately scraping becomes live data connector. So, scraped data sounds very useful, right? Well, web scraping might sound straightforward at first glance. You know, just send the bot, grab some data, done. But anyone who spent time scraping at scale knows it's anything but simple. Web scraping comes with a wide range of complex challenges, but today let's just go through two main ones that web scraping engineers face daily. So the absolute biggest obstacle in web scraping is simply getting content you want without getting blocked. It's not like that websites are hostile to visitors, but they aren't really rolling out welcome mats to bots either. So today, many websites use sophisticated methods to identify automated traffic and block it whenever they spot signs. If your scraper's fingerprint isn't quite right, maybe it mishandles something very subtle like TLS handshake or HTTP headers, you get blocked. So if you're building a scraper, your scraper's fingerprint needs to look like it's a natural user's. Even geographic locations can matter. For example, imagine scraping an e-commerce website that sells goods only in the US. If your scraper appears from outside the US, it's game over again. And even if you've done everything correctly, you may still hit that CAPTCHA. And now the challenge is to detect it so you can trigger a retry. Making things tougher, anti-bot technologies constantly evolve. Scrapers must continuously adapt. And finally, each website implements their own protections and anti-bot solutions, meaning this is even more complicated when we are scraping at large scale and many different websites. Now, remember I mentioned detecting bad content? Now, imagine you're scraping a product page, you send a request, and you get this HTML back. Now, it looks like a mess, right? But the big question now is this what we expected? Well, it turns out it wasn't what we expected at all. It was a CAPTCHA instead. So the server detected something suspicious, and instead of the real content, it served us this. Now, recognizing it and to trigger a retry is not that easy because CAPTCHA layouts vary widely across sites. And worse, these layouts constantly change. So to reliably detect that this was not what we expected and blocked content, we need to keep track of all these different layouts and structures. Otherwise, we may just treat garbage HTML as valid data. Now, let's say you got the right page, great, but it's still tangled mess of HTML, a chaotic jumble of code and tags, often with far more irrelevant data than useful information. Your task now is to dig out relevant data points, product names, prices, ratings, Typically, you'd use parsing solutions and libraries and write manual selectors for each data point you want. Let's say snippet I'm showing here is from a product page, and now you're specifically looking for a price. I will highlight it, but trust me, without the highlights, spotting these data points is really challenging. You have to manually set data selectors, identifying each unique element. But your challenges aren't over yet. Websites constantly change these layouts and structures. So when it happens, your carefully constructed parsers break. And that is not a question of if, that is a question of when. Now multiply that across thousands of sites, and it basically becomes a maintenance nightmare. Well, luckily, for some of the headaches that scraping presents, we now have AI as a powerful ally to help us and tackle these challenges head on. How? Well, one effective way is through what's called classification model. These models learn patterns across HTML structures from many different websites. First comes data collection and identification. You collect large volumes of HTMLs, and then you identify relevant features and structures. So XPath def, visual position, even nesting, and let's say tag frequency. Next, we move to accurately labeling collected data by identifying and marking raw content according to what it actually represents. And then we have the model training phase. Here we feed the model labeled examples through multiple iterations. And once a certain threshold of familiarity is achieved, the classification model can accurately identify relevant content even from websites it has never encountered before. Now, these classification models can be used in many ways, but two that stand out in the context of web scraping are AI response recognition and adaptive parsing. So one big issue in scraping is making sure the content you received is actually usable. And as I mentioned earlier, doing this manually is resource extensive and takes a lot of time and effort. This is where AI-powered response recognition comes in. So websites often return status code 200, even when your scraper is blocked and you are served with a CAPTCHA. The classification model analyzes HTML content, checking if the response contains signs of blocking elements. Now, labeling in this case is very simple. Each HTML is labeled as either containing blocked content or not containing blocked content. But because web scraping happens worldwide, the model is trained to recognize blocking elements across diverse set of languages, layouts, and styles. Once trained, this AI model works within a smart feedback loop. When it detects blocked content, it triggers every try. The second big way AI helps is through what's called adaptive parsing. Parsing basically means extracting structured data, but adaptive parsing goes further. It adjusts automatically with each layout change. Traditional parsers rely heavily on fixed selectors and needs maintenance. For example, when trained on product pages, the model can consistently parse product titles, prices, attributes, images, and other details. Instead of depending on manually written fragile rules, the AI identifies meaningful patterns in the HTML structure itself. It allows it to generalize effectively to new websites and new layouts. As the model processes and learns from more examples, it becomes even smarter, more accurate, and resilient to changes. Now, for the demo, we will be shifting gears a tiny bit. We won't focus on the tools that we just discussed, but I will show you another fun way and how AI can be used in the context of web scraping. So let me introduce you to our playground. This is where you can actually test various requests and put some parameters. You can do that manually over here where I'm just showing now. You can put the geolocation, what layouts do you want, is it desktop or mobile, or you can use our Oxy Copilot, which will generate the request for us. So here we just put some URLs. The more you put, the more accurate it will be. But the more time it may take. So I'm just going to put free. Here we can put other parameters that we want. Maybe we want to scrape it from another geolocation, or maybe we want a slightly different layout, for example, a mobile. And here we simply put what we want to extract, what data points we want to extract. So here we are trying to be as precise as possible, just like with any AI really. So the prompt needs to be quite detailed for it to do things correctly. Yeah, so we are just going to be extracting a few product details. So this is going to be search results with a list of products. And for each product, we'll be extracting certain data points. So what will happen now, this prompt is sent to the API. And as you can see in the background, the code is slightly changing already. So it's putting some details in there. It does take a minute, but just because I put 3 URLs, so it is scraping all 3 and analyzing the 3 different layouts of the HTML. So it can take a second. And here we have a result, so we can double check. There's a price, the title, and the rating parts there. We can change the types of our data in here manually. Or we can simply adjust the prompt here. So what I didn't like here, it was that the number and the currency symbol is in one field. So I'll just separate it and ask for the price as number and then currency separately, and then generate again. So what this AI is generating is what's called custom parsing instructions. So instead of using our built-in parsers, you can send custom parsing instructions just for the data points you want. And here, AI generates it for you. So as you can see, it fixed now the price is as number. We save it, and now we have all the requests with all the parsing instructions ready, and all the example codes are there ready to be used. So you can just take that code and use it in your implementations. Okay, so when it comes to implementing web scraping solutions, businesses face a crucial decision. Should we build our own scrapers, or should we buy ready-made solutions? Now, building your own scrapers, scraping infrastructure gives you full ownership, but it comes at the cost of high initial investments. People, resources, and potentially a slower start. On the other hand, purchasing solutions can dramatically reduce costs and minimize complexity. The trade-off, potentially less flexibility, sorry. Okay, and that brings us to the end of my presentation. And just to conclude, scraping supplies fresh, high-quality data for AI, while AI makes scraping smarter and faster. Thank you for listening.